Yeah, my name is Daren Fulwell, IP Fabric Product Evangelist. I'm here today to talk a little bit about how basically the work that we've been doing with the guys at iTensure in order to really augment the two products really and show how they work together to give you something a little bit extra. We called the session Closing the Loop. It's a little bit more than that, but we'll dig into that as we go. So you've already seen this slide, I hope. This is basically the story that the guys at iTensure have just been telling about the fact that a network is a network of networks, not just one. The fact that in order to deliver network service, you've got to orchestrate all of those elements to changes across all of them in order to make a service work. But in order to do that, you need to pull data from other data sources. You need to be able to integrate that into an operational workflow. You need to make sure that people are notified as they go as to what's happening. So super important. But at IP Fabric, what we do is we take a bit of a broader look at the validation of a lot of what's going on the network. As you build those network automation tasks out, obviously you build tests into the process. There's a lot of unit testing that we do, but every task needs its own dedicated test, and you need to make sure that it's having the impact you expect. For example, if you're, I don't know, bringing up a subnet in your cloud infrastructure, you need to make sure that subnet is redistributed through the WAN so that it's accessible from the LAN and so on. So your changes are much more complex than just making a config change and looking that config has been fixed in a particular point in the network. You have to understand and validate the entire infrastructure in order to make sure that it's done the thing you expect. And so what IP Fabric does is gathers the end-to-end view of those network of networks, kind of the reverse, I suppose. We're picking out all the data from all of those domains, bringing them together and modeling that infrastructure so that you're able to understand the impact that a change has to make sure you think it's doing the thing you expect it to be doing. Now, of course, the way you would have approached that back in the days is to fetch all of the bits and then manually hack your way through to work out whether that was working all right. But the problem is there's a lot of stuff that you need to validate. You need to make sure that you know all of the devices in the network. You need to make sure that you have a full understanding of every domain. So there's an element of checking documentation, right? Making sure that documentation is good and solid and that everyone knows exactly what's going on. You need to check the configuration of those individual devices and make sure that the intended state for those is as expected, whether that's from a management plane, control plane, data plane perspective. There's all of those things that we want to validate and comply with standards and so on. And then you've got to look at the state of those devices to make sure that what config is there is actually having the desired impact on that individual device. It may be that you configure something, but something else somewhere else is causing a problem. So you have that whole validation process within the device. But of course, it's not just about one device. It's about the wider picture of the relationships of those devices with the devices surrounding it in the domain and between domains. So it's then a question of understanding how routing protocols are working, how forwarding is working between from device to device, how those interactions and the complexity they bring is actually impacting how traffic is traversing the network. And that really dictates that end-to-end behavior, that idea of saying, right, I know that if I've got a sensor on in a particular office location, to get to the VM that's up in Azure that supports that, this is the path it's going to take, and this is how that network is going to deliver the traffic that I'm looking to deliver. Trying to do that manually, horrendously complicated, obviously. And it needs a lot of tribal knowledge, a lot of skill in the individuals involved and so on. And comes back to that documentation piece, right? Always making sure that documentation's up to date. But without having that automatic view of those things, then how do you automatically validate a workflow automation? It's really tough because you have to do all this individual unit testing of every change. Well, thankfully, with IP Fabric, that's the point. You don't need to do that because we'll automate the capture of this information, the building of a model of the network in order to validate this information. And then we can layer checks on top of that in order to make sure that you're getting what you expect. And I've got a quick flick to the UI to show you a little bit of that. So this is IP Fabric's UI. And what I've done here is I've just taken the liberty of creating a dashboard. If the Wi-Fi lets me connect to it, there we go. With just some tasks to show you the kinds of things that IP Fabric brings. So the top two here are looking at the inventory of the network. So we do a discovery based on CLI, on API into controllers, using whatever mechanisms we can in order to discover the whole of the network.
Are those definable, Daren?
The dashboards.
The mechanisms by which you gather all that information.
We default to SSH if it's a command line. We'll hit telnet if telnet's available. Ultimately, that's it from a command line perspective. We don't use SNMP and so on, but does that answer your question?
I'm referring more to the scripts themselves. So let's say there's a new device that comes along and we're SSHing in, and that's fine.
Yeah.
But IP Fabric doesn't know how to get the information it needs. Can we script that and say, pull this, pull this, pull this, and provide the information ourselves?
No. So IP Fabric uses our own parsing in order to connect to devices. The first time we connect to a device, we determine what type of device it is, and then we'll run the commands that are appropriate for that model, that platform, to bring the data into IP Fabric.
But if it's all new and IP Fabric has never heard of this device,
if we've never heard the device before, what we'll do is we'll discover that it's there, but we're not able to parse the information out because we don't understand the commands, I guess.
And
what we then do is we work with the customer who's discovered these things in order to deliver that into a later version of the code.
Okay, that works. Thank you.
What about devices that don't have an SSH, telnet, Meraki, etc.?
Right. So Meraki, we go to the dashboard, for example. So if you've got a controller that's looking after the thing, then we'll API into the controller using whichever mechanism. So long as you feed the credentials to IP Fabric, we'll go to those dashboards, we'll go to all the devices, and we'll work our way through. Ultimately, that's if you've got a completely traditional network, you can literally just feed us the credentials, and we'll just go find it based on the default gateway of IP Fabric.
And like if we were trying to use this as a discovery tool for like a consultant going into an unknown, do you have capabilities to at least identify, hey, we're pretty sure there's a network device off this port, but we have no clue what it is?
Absolutely. The discovery approach is much the same as if you were to sit down in front of the network yourself, right? So you log into a device, you understand. You look to see if there's CDP and LLDP. That's, of course, what we all hope for when we're looking for more devices on the network. But often that's not the case, for security reasons or whatever. No, we'll look at spanning tree neighbors. We'll look at BGP peering. We'll look at routing table entries. We'll look at all of the things that indicate that there's other devices there that you need to access. If we can't log into it and actually determine what it is, we flag it up and say, we know there's something there, but we can't tell you what it is yet. And then what you can do is go back and either fetch new credentials and try those, or you can look to see what's going on, basically.
Perfect. Awesome. Thanks.
Okay.
So maybe I'm getting a little bit ahead of us, but could you use the sense of time of how long it would take to crawl a network?
Sure.
Like in that consulting scenario.
Yeah, I mean, it's... just trying to think, we've got a demo environment of about 600 devices, let's say. That demo environment, to discover that fully, takes between 20 minutes and half an hour, right? Because obviously what you're doing is going through that crawling mechanism. There's all the layers of intelligence there, but we're able to run 30, 40 CLI sessions at once, which is a little bit quicker than I could do it when I used to do this stuff manually, right? But that's the sort of numbers we're talking about. Obviously, if there's a lot of API discovery in there, your mileage varies. But okay. So yeah, so what we've got here is as I say, this dashboard just gives us an indication of the kinds of things that you might pull in those different areas. The first couple of things here are based on inventory itself. So these are, for example, end of life and milestones that might be against devices. And I'll just turn that filter off. So you can see we've got a whole bunch of inventory down here, and everything's color coded green, which is great. That means that we have no end of life announced. But if I just search this slightly differently, you'll notice that actually I've got some here which are showing up as blue, and what that means is that the end of sale has been reached for these devices based on the values in here. So these essentially, these intent rules that we're seeing up here are just filters on the data that we've collected. And all of the data through the platform is displayed in these quite simple to use spreadsheet type tables, right? So you can filter these, you can sort them and do all the things you would expect to do with them. You can export the data from these as CSV. You can even, if you really want to, and we will see this later, is extract the information over API just by clicking here. You've got the API call and the details that you need to bring that very data out of the platform. And this mechanism obviously is then how we'll come to it later, but how we interface into, for example, Attentional. So if I go back to the dashboard, so we've looked at inventory. I'll just touch on some of the, for example, the configuration. I'll just flip to a different snapshot. So yeah, from a configuration perspective, we might be interested in, and this is what, it's one of the standard use cases, I suppose, for from a management plane perspective, is the is SNMP, right? So what we've got here is we've decided to classify these as green because they've got a custom SNMP configuration, which, but you'll notice we've got some yellow devices here which have a configuration that's defaulted. So very quickly we've identified, right, okay, here's a bunch of devices that need some attention. We need some config change. Let's go resolve those and deal with that. We then move on to into state, and I will look at the, let's look at some BGP. So in this situation, what we've got here is we've got a whole bunch of MPLS enabled routers. And what I've got identified in this table here is the BGP neighbor relationships between PEs and route reflectors. Now, it may be that if something gets misconfigured and someone builds an IBGP relationship to a device that's not a route reflector, then I want to flag that up because that's a mistake and that needs to be fixed. So I've got a intent verification rule here that colors this based on that fact. If it's going to connect to something else, what I'd end up with is a yellow item in the list. And if I want to look at eBGP sessions, so this is connections from the PE out to the CE, then I can flag those as blue because they're something completely separate. So again, it's taking the configuration of the BGP and being able to classify it and show that it's either as we expect it to be or not. The beauty of something like this is we're actually bringing that together with state data, and we can start to talk then about that session's configured, but is it established? Is it doing the thing I expect it to? Am I receiving prefixes over it? And because again, we can bring that into the table, again, we can filter that. So you can see over on the right-hand side, we've got the status and the prefixes, and we can show where basically a backup link that's connected to a PE may not be able to pass traffic because it doesn't have any prefixes associated with it. So we can very quickly identify these things using the intent rules. Once we've built the model then from all of those aspects, that inventory, that config, that state, what we then can show is how the topology of the network's built out. There we go. So you see here, we have a topology diagram that IP Fabric has built automatically. The way that it's built this out, and I'll zoom it in a bit so you can see more clearly. I'll zoom in on this head office location here. What we have shown on the diagram here is a bunch of colored lines, right? Those colored lines represent the layers at which we've discovered adjacency between devices. So you can see blue for layer 2, you can see green for layer 1, and so on. Just basically using the protocols that we've discovered as part that are in the tables that we were looking at previously. I mean, it's a very simple but very effective way of showing the topology, because we can, and just to prove that we can do this without needing the discovery protocols, I can remove those, and you can see it's still got the topology, still see how everything's connected, because I've used the state of the device to determine what that topology looks like.
Question: When you're
Please.
first creating these diagrams,
Yeah.
are they that pretty? Or they require some manipulation?
There has been a little manipulation in this case, but we do have plenty of options for the diagram layout. So we have what's called a universal layout, which just gives you a spaced layout that generally works well. But these are different algorithms here. You've got circular, hierarchical, and so on to give you some baseline. Then once you've done that, you can lay it out then exactly how you want it. Store that. And next time you run a snapshot of the network, you'll get that same layout back. You can also save views, like the views that I saved of the whole network there, to share amongst all the users of the platform. So,
question,
please.
What if my V4 topology is slightly different than my V6 topology?
That's a very good question. What we do is we use a single topology. In effect, we take the devices and we overlay these relationships, as you saw on the diagram here. If you've got V6 layout, which we're just in the process of introducing into the platform, the layout in V6 now, what you would see is the same physical locations of the boxes, obviously, because you've placed them that way, but you would see the relationships between the devices shown however it is. So really, it doesn't matter that it's a different topology. The layout will stay the same, and all you need to do is turn on and off the different protocols.
So you may have a V4 versus a V6 selector there.
Exactly that. There would be a V6 selector, which is why I'm saying that it's not in the visualization yet. Okay, we do. As we introduce new technologies into the platform, what we do is we first bring them into the discovery and the modeling, then into the visualization, and then into the more detailed intent verification. So, okay. So the last side of the visualization is path lookup. Now, this is kind of what this is doing. Really, is bringing together all of the aspects into one place. Because what we can now do is basically create a visualization of the behavior of the network end to end. I'll just put that away. Zoom that a little bit so you can see a little more clearly. So what we have here, for example, we have a sensor that's connected to a router. That sensor is trying to access a workload that sits up in Azure. And what we're showing here is the path that it will take to get there. Now, we can dig into this in gory detail. We can look at, for example, the forwarding decisions that have been taken to make that happen. And I'll show you very briefly what that looks like. You can see here I've got 4 input potential inputs into that router. So once I've gone through and chosen one of those, effectively what we do is we simulate a packet passing through the model. So you've got this idea of headers in and out, and you've got the decision that's taken in the middle here in order to get from ingress to egress. And if there's any policy that's deployed in the network, firewall policy and so on, what we'll do is we'll incorporate that into this decision as well. And then you'll get a yes or no, I'm able to pass through the network or I'm not. And we'll show you a little more of that in the demo later. But again, the beauty of all this, I've shown you all this stuff in the UI, is that everything you see here is accessible over the API, including this path lookup. So what that means is all of the checks, all of the intent checks, all of the path checks that we've referred to are all accessible as part of the automation workflow. That means then that we're able to basically take that assurance and use it as a way of closing the loop, right? We have these different ways in which assurance is increasing the value of automation by being able to measure the success of a change end to end. So once the change has been executed and iTential's gone ahead and made all the changes across all of the different network domains, because IP Fabric understands all of this, it can validate that the network as a whole is going to behave the way you want it to in order to deliver the outcome you're looking for. So we can use that as a way of feeding into the automation process to say, yeah, that's all good. Let's or no, it's not good. There's something that needs to be changed and modified, and so we'll go ahead and do that. Of course, having all that data in the assurance platform gives you other options as well. We can do things like validate the data that's in those sources of truth. If you've got an IPAM that's not fully up to date, how do I make sure that I've got the actual live state? Well, I can pull it through because I've got it all in here. I understand all the IPs, I understand all the interfaces. I can drag that information from the assurance platform. And you can use that in the workflow logic itself, because you can run filters on the data that's in IP Fabric and say, tell me all the devices that need an SNMP update. I can find those devices from IP Fabric, can use that as a way of limiting the scope of whatever workflow I'm actually activating.
So Daren, we've got the model in your product, and obviously we can see what happens after we've made a change.
Yeah.
Is there any way to model a change before we make the change?
What a great question. The problem with that for me is always that the scope of the change, it's kind of this problem we've described down here. In order to validate what a change is going to be, what you have to do is simulate the entire network to make sure that's going to be valid.
I thought I'd ask.
But I understand what you're saying.
It's the feature that several of my customers have asked for, that from various vendors, not just yours. And I'm just like, well, it's worth asking.
No, I understand what you're saying completely. I think there are corner cases where you're able to do that relatively easily. For example, making security policy changes and that type of thing. The way we would approach that is actually flip it on its head and show you what can and can't be done with the network as it is, and so highlight what needs to be done in order to fix it. Then validate after the case. But really, things like a routing change or something like that doesn't just impact down here; it impacts over here. So you would understand the whole.
And that's the big problem for the customers. They're trying to understand their change management process when, well, the guy over here says, well, this is not going to change anything other than this little thing, and then it cascades. And
I think the beauty of the problem with that is that people don't know what the impact of one thing is on the other, and at least by having the data about that and in the platform, we can show that we can clearly say, look, this impacts this. This is how we move from one to the other.
On this particular slide right here, where would we draw in like observability, monitoring, or documentation? Would that come back through automation or directly from assurance?
I think, personally, I would say it's definitely over on this side. I think what they really do is augmenting operations, right? And so the operational aspects are very much on this side. And to be fair, you could quite comfortably use those as another form of input into the automation process.
Maybe it would draw a triangle there, the diagram of a
well, the triangle is the triangle is really the sources of truth for the intended state. It's the automation, the fulfillment of that intent, and the assurance then becomes a more of a group of capabilities, I suppose, to validate that yes, the network is doing the thing it should.